Hey guys, this is Mass World, and today we'll be treating a very important topic that is titled Law of Indices. Well, this topic is not new to many people that know much about mathematics, but then some persons may still have some challenges with it. That is why we are here to make it very simple for you. Now, it's titled Laws of Indices. Let me just correct that. Laws of Indices. So very simple. You look at that statement, laws, then of indices. So when you talk of laws, you're talking about guidelines to be followed, rules to be followed. These are guidelines or rules. Talk of laws. Then indices mathematically has to do with powers, right? Some of us might have heard of powers. For example, you have let's say x raised to the power of a. Yeah, the x there could be an integer, or could be a number, yeah, which could be an integer, could be like this is a letter. Then you can see the a there. The a is actually the power. Yeah, the a is the power, while the x is the number that carries this power. For example, if you have like 2 raised to power 2, the 2 is the number. The second 2 up here is the power. And so when we talk of laws of indices, we are talking about the laws that can be used to solve problems that involve expressions like this that you see. For example, you could have 5 raised to power 2 multiplied by 3 raised to power 6. Now this is a mathematical expression. How do we solve this kind of problem? So there are several laws that can be applied to deal with situations like this. You could also have something like, let's say 2 raised to power minus 3. Then there's a bracket. Then you have 4 outside of here. So how do you deal with problems like this? You can solve problems like this with some guidelines. There are laws you can apply to solve problems like this. So these laws are referred to as the laws of indices. So basically, I'll give you 7 laws of indices that can be followed. When you see expressions like this that I've presented to you, you could see of these 7 laws which one applies to them. Then you could just pick the law, apply it to it, then solve it. It's as simple as that. So it's very simple. And these laws I will list to you for the very first one. The very first law, law 1, is if you have an expression such that you have x raised to power a multiplied by x raised to power b, how do you express this kind? How do you solve this kind of problem where you have x raised to power a multiplied, this is x, so don't confuse it, multiplied by x raised to power b? So it is very easy. All you just need to do is observe this expression. You see that you have x here, you also have x here, meaning they are the same thing, right? And you have powers. Now these powers could be the same, not compulsory that they are different. It could be the same, but I just deliberately made them different. But the most important thing is when you have expressions like this, all you just need to do is just pick one of these 2 similar letters here. Just pick one of it. Then you see the powers. You add the powers together. So you have this. Now, what do we mean by this? If you have a power raised to power something like what you are seeing here, you have a number, raised to power a number or a letter multiplied by another number raised to power a number or a letter. All you need to do is, as long as they are the same, you just pick one of it. Pick one of the numbers or the letters. In this case, you can see x raised to power a multiplied by the same x raised to power b. Pick one of them, and as long as they are being combined together, joined together by a multiplication sign, you then need to add the powers, right? So for example, if you have something like this, for example, you have, say, let's make it very simple, 2 raised to power 3 multiplied by the same 2 raised to power 5. All you just need to do is you pick one of these, which is 2, then you add up the powers, then you have it as 3 plus 5, then you end up with 2 raised to power 8. It's as simple as that. Now 2 raised to power 8 can also be further expressed. That is 2 times 2 times 2. You have 8 of it, right? Where you have 2 raised to power 5 as 32, 2 raised to power 6 as 64, 2 raised to power 8 will give you 128. So you can further express this as 128, right? So, but the most important thing to know here is this. As long as, observe this example, you see you are seeing 2 here, you see another 2 here, and but their powers, the powers can even be the same. You could have 3 here as well. But the most important thing to know is that as long as you have 2 here, you have what is here is what is here, right? And they are joined together by a multiplication sign. Then you have to add up the power. You add up the power. Let's take another example beside it. How about if we have something like this? We have x raised to power 3 multiplied by, let's say, x raised to power 4. It's as simple. What we just need to do is we'll pick one of these, right? X. Then we add up this power, which is 3 plus 4. Then you have something like s raised to power 7. In this case, we can't further express this. We just leave this as a final answer, which is the final answer. So this is the very first law of indices. There are other laws of indices. I told you there are 7 laws I will give you today, but this is the first law. The second law of indices states that if you have an expression like this, x raised to power a divided by x raised to power b, all you just need to do is pick, just almost like the first one, you pick the first, you see the x there, you can pick one of the x, and you are seeing a division sign connecting these two terms here. This division sign, once you see it's a division sign between these two, all you just need to do is subtract. Let there be a subtraction sign between these two powers. Then you have like a minus b. You see the difference? Almost the same thing with the first one. But the difference is there's a division sign here, and we are subtracting one of the power from the other power. It's as simple as that. So in this case, we can also apply what we did. Look at the very first example. For the very first example, we said 2 raised to power 3, right? But this case, let's assume we have divided by 2 raised to power 5. So that's the first example. So 2 raised to power 3 divided by 2 raised to power 5. What's that? You see, look at this expression. It looks like this, right? They're almost the same thing. See, 2, looking similar. A can be 3, 5 is B. All you just need to do is pick one of the expression, which is 2, right? Then subtract the 5 from the 3. Then you have this 3 minus 5. 3 minus 5. It's as simple as that. And so you end up having 2 raised to power 3 minus 5 will give you what? You have minus 2. So look at this expression. Just take a good look at it. What do you see? We discovered that they are the same, right? Just like x is the same with x. And they are powers. Not compulsorily that they must be different. They could also be the same, just like the first one, right? But the most important thing is that as long as the division sign and this expression, this number or letter, in this case it's number, must be the same with this. So it's compulsory that this is the same with this, and there is a division sign before you can subtract the power. Those are the two conditions. X must be the same with this x, and you can then subtract the power, right? So if you have something like x raised to power a divided by y raised to power b, you can't apply the law of indices to them. No, they are two different things entirely. Just like if you have x raised to power a times y raised to power b, it won't work. It won't work. These laws will not work for them. So it's your answer. So this is laws of indices, right? This is the first two laws. So I have like 5 more laws to present. And so if you could practice more and more of questions like this, you get used to it. At times they don't just come straight forward, but you just need to have a sharp eyes to really find them in the questions and see which one applies to this first law, this second law, and you can just simplify and get your answer, right? Now we come to the third law of indices. The third law of indices is law number 3, right? Now the third law is very simple. We can say anything x raised to power 0 is 1. Now it's as simple as anything raised to the power of 0 is 1. 1 million raised to the power of 0 is 1. Y raised to the power of 0 is 1. Minus 2 raised to the power of 0 is 1. Anything raised to the power of 0 is 1. So simple, right? As straightforward as that. That's the law 3. Very, very simple. Somebody says 0 raised to the power of 0 is 1, right? Can you prove that? I'll leave that to you to discuss in the comment section. Well, z raised to the power of 0 is 1. Anything raised to the power of 0 is 1, right? And so this is the third law. Let's go to the fourth law. Looking at the fourth law of indices, we might have seen something like that in what we did before, right? Where you have something like x raised to the power minus a, x raised to the power minus a, but x raised to the power minus a, x raised to the power minus a is actually equals to 1 all over x raised to the power of a. Yes, 1 x raised to the power of a. Why? Why is it so? Right? Because it's been proven. There are proofs to this, right? But the most important thing, what you just need to get from this video is this. Whenever you see an expression that looks like this, x raised to the power of minus a, all you just need to do is observe you have 1 all over x raised to the power of a. For example, if you have, let's take an example beside it. Example, you have, let's say, let's still go with the x raised to the power minus 2. So how do you solve this? You have 1 all over x raised to the power of what? 2. It's as simple as that. Just very simple. Very, very simple. So it's so direct. You don't need to. We could also go on and on. You could have like, let's say, 5 raised to the power of minus 2. Somebody may say, whoa, this is looking somehow big. There's nothing big here. It's actually straightforward. 5 raised to the power of minus 2. All you just need to do is follow the rule, right? Just follow the rule. Look at the x here. The x is the 5 here is representing x, right? You see the 2. The 2 is representing a. It looks like this. While the 5 is representing x, the 2 is representing a. All you just need to do is follow the rule. Then you have 1 all over. See the x here. And what did I say the x was representing? You can see it's representing 5. You write the 5. What did I say the 2 was representing a? Which is expressed as this. You write the a. But this time you don't write a. So you have to write 2. So you have 1 all over 5 raised to the power of 2. But 5 raised to the power of 2 in mathematics, index form, if you are good with your index form, you know that 5 to the power of 2 is the same thing as 5 times 5, right? That's 5 times 5. And 5 times 5 is what? It's 25. So you have 1 all over 25 as your final answer. It's so straightforward, right? Very straightforward. All you just need to do is, right? So it's so straightforward. All you just need to do is just follow the rules and you get your answer. Okay, so we come to the fifth law of indices, and the fifth law of indices, sorry, let me just write law of indices. So the fifth law of indices says if you have x raised to the power of a in brackets, then you have a b, it will mean that you multiply this power, a times b. So you have x raised to the power ab. Now, how important is this law? It's important because if you have an expression like this, for example, x raised to the power 2, and you have 3 out here, and you get something like, that's 2 times 3, becomes x raised to the power of 6. It's a very, very important law, and this law can apply to situations like this. This is the fifth law of indices, the fifth law of indices. Now, we also have the sixth law of indices. The sixth law of indices says if you have an expression like x raised to the power of a fraction, we call it fractional indices. You have something like this, 1 all over a. So x raised to the power of 1 all over a, it can be expressed in this manner. You have a to the root of x. A to the root of x. Just take a good look at that. X raised to the power of a. Then you have a to the root of x. And so you have an expression like x raised to the power of, let's say, 1 all over 2. Definitely you have the second root of x. But now in mathematics we don't include 2. The roots talk about root of numbers. It begins when you begin to write the number in front of this root is from 3 upwards. So for second root, which is the same thing as square root, you don't need this. You only have in cases like this, 1 all over 3. Definitely if you follow this rule, you have cube root of x. And so in this case you can include the 3. For fourth root you can include the 4. Fifth root you can include the 5, and so on and so forth. These are what is referred to as fractional indices. Now this law also is similar to what we have in law number 7. That's law 7. For law 7, we also have something like this, x raised to the power of a all over b, and that gives you the b root x. Then you open your bracket a. You can see how it is. Very simple. B root x raised to the power of a. And so if you have an expression like this, take for instance, for example, you have x raised to the power of 2 all over 3. You can express this, you can solve this by representing it this way. You have, look at the 3. The 3 is represented as b, similar to b. And so you can just you can see it, the 3 come here, root of, look at the 2 is outside. But what is inside? X, right? The x comes inside. And you put it in brackets, and you can put the 2. Let's take an example of this. For example, if we are asked, example, if we say, let's just solve this, we can say, let's just solve, let's say, 8 raised to the power of 2 all over 3. Or simplify, right? Simplify, just solve it. Let's just solve this. Or simplify this. Then you have this, it becomes If you want to solve x raised to the power of 2 over 3, you end up having cube root of 8, because it follows law 7, right? Look at it, where 2 is representing A, 3 is representing B, and so you have the cube root of 8, close the brackets, then 2 is outside. If you check the cube root of 8 in your calculator, you have 2, right? Then the square is still outside. So 2 square is same thing as 4. So this is how you solve law of indices. Our next class will try to solve complex problem and apply these 7 laws in simplifying indices, mathematical problems that relate with indices. Thank you. Please subscribe to this video, like, so that you can get more content. Thank you.